Good morning to all. Welcome to imageGrafix webinar. Today's topic is 3D modeling and the detailed drawing generation of static equipment. Today we have a presenter. My name is Ahmed Higazi, CAD Solutions founder and SEG owner. Before starting in our presentation and demo, I'd like to highlight about imageGrafix. imageGrafix is founded in 1996, headquartered in Dubai. imageGrafix has different group of companies and engineering divisions: engineering services, software solutions, enterprise solutions. imageGrafix have more than 130 employees and growing. You can visit imageGrafix website www.image-grafix.com. imageGrafix has a view of locations in India, Mumbai, Chennai, New Delhi, and in United Emirates, in Dubai and Abu Dhabi. Regarding to CAD Solutions, it's founded in 2019, headquartered in Egypt, and located in Cairo. Our website is www.secadsolutions.com. Last year, we had a webinar regarding to SEG Software and introduce it as one of the most important solutions for the 3D modeling and the detailing for static equipment. In the next few slides, we will review some points that we discussed in the last webinar. After that, we will start in our topic directly. Here by SEG Software, you have the ability to create horizontal and vertical pressure vessels, columns with multi-sectional sections and different diameters, storage tanks with fixed roof, and all attachments like spiral stairs, clean outdoors, manways, heat exchangers, TEMA heat exchanger types, piping, ducts, and Slug capture. All of those equipments under one umbrella. And in last our webinar, we discussed one of our tools, which is the integration tool between BDL and SEG Software, and how we can export the MDB Access database file and import it in SEG to create the 3D model. After that, make your customization tool suits your fabrication requirements by using SEG. After that, creating your details and the general arrangement drawing. Here in this video, we use this integration tool to create a pressure vessel created by BDL, and here we will import the exported database file from BDL and modify some data during importing, like longitudinal welding line orientations of the shell courses. After that, you can figure that all the tree is built automatically regarding to the importing data from the access database file. Now we will save the data of the equipment. After that, we will proceed to create the 3D model of the equipment. Okay, like that. You can figure that all items will be created automatically and assembled automatically for the equipment. Now we will start in our topic, which is the TEMA heat exchanger and the available types in SEG and what's the support types in SEG. That's a famous figure for the TEMA types, and all of us know that TEMA types has three parts. The first part is the front end, and the second part is the gel type, and the last part is the rear end. Here in SEG Software, you have the ability to create 5 items from the front end, type A, B, C, and N. Okay. For the shell side, by using SEG Software, you have the ability to create all shell types according to TEMA. And for the rear end, you have the ability to create those types. And those are the most common types of heat exchangers. And they are the most common, as I told you. Here, That's the front side components, and you can figure that each type for the front end, like A, you have two cases, B, which is a bonnet integral cover, C and N. For the shell type, all types according to TEMA, you can do it by using SEG software, if it's a water shell or a kettle type. And for rear end, you have the ability to create those types, bended tubes, or which is the U-tube, or with using a straight tube with a floating head or a fixed tube sheet. And here, that's in this figure, you can find some most common types of heat exchanger like AES and BES with a floating head types, and the kettle type, which is AKU and EKU, and AEM, BEM. Those are most common types, and you can make it easily. And we will make a demo, inshallah, for the AES exchanger and EKU exchanger. Here in this video, the old way, this video will show you the old way to create the exchanger by adding element by element. For example, in the channel side, if you would like to make it like type A, you will need to add a blind flange and select the suitable type of this flange and fill all data by hand for each element. And after that, you will add a gasket, after that another designed flange and shell and another flange. So it takes a time from you to generate each element, and takes a time to fill all data again on the same connected flange. Okay. But by using SEG software, we create a new feature or a new tool for heat exchanger to make this part easy for you. And we add a new module for the parametric modeling. In this module, you can make a relationship between two parameters. For example, if you would like to make a shell inside diameter the same with the head inside diameter. So by using this module, you can make a relationship between parameters and each other. In this video, here we have a head and shell. And you can figure that the inside diameter of the head is different from the inside diameter of the shell. We will open the parametric and relationship module and make a mapping for the parameters. We will select on the left-hand side, we will select the left head and select the inside diameter. And on the right side, we will select the shell and the inner diameter of the shell. And we will make a mapping for those parameters. Those parameters, in this case, will be equal to each other. So in case of changing one of them, it will be reflected automatically to the other one. Now let's change the inside diameter of this head. Let's make it 1500 and click Save. Now if you go back to the shell, you will find the inside diameter changed automatically because we make a relation. Now we will make another relation between the thickness of the head and the thickness of the shell. The same way we will select from the left-hand side and right-hand side, select the parameters in two sides, and now we have a new relationship between the parameters. Okay, now if we change the thickness of the shell, it will be reflected automatically to the head, like this. Okay, now we will start editing our demo, inshallah, and from here we will open SEG software, and from here we will start a new project. And let's create a demo for AES heat exchanger and select the location. Let's create it on the desktop, and from here select the heat exchanger module. We have many different modules like pressure vessels, horizontal, vertical, and ducts, tanks, and piping. Let's click Finish. And now we have in this tree the heat exchanger, and let's make a rename for our equipment, AES exchanger, and let's click Enter. And from here we will modify the setting of this equipment. We edit the setting of the equipment. You have the ability to define the position of the vessel, define the delivered blade dimensions, and those dimensions are used in the calculating of the circumference of the shell. SEG automatically detects if the blade length will cover the circumference length of the shell or not. If not, SEG automatically will calculate the required number of plates to cover the circumference of the shell. Here you have the ability to change the units of your project. From here we will modify the setting of the making the parent and child preview and click Save. Now we will start creating the heat exchanger by clicking on set changer side and click Create. From here we will select the vessel and define the clearance according to imageGrafix. According to this image here, the clearance is the clearance on diameter between the inside diameter and, for example, for the raised face inside diameter of the flange, and according to this figure. Now we will click Start Exchanger, and from here you will find 3 tabs for the front, shell, and rear. If you select the front side, you can figure that you have this type of shell of front side, and you can change it to the second case with a cone, and you can figure that you have the elements of this one appear on the tree like this, the B type, N type, like that. Let's make it A, and you can figure that we have a blind and automated parameters link it to the other parts. So by using this module, you will create automated parameters, and we will discuss that in another slide. But let's select the shell side, which is E, okay, like this. The rear side, select S. Okay. Now we will create build to create those items on SEG tree. Here you can figure that in your project you have one exchanger. The type of this one is AES, and that's the figure you will get it when you create equipment. Here you can figure that this tree is filled automatically with the elements of the heat exchanger, and we have 3 groups. For the front end includes those items, which is blind flange, gasket, another flange, shell course, and another flange, tube sheet or tube bundle, shell side, and the rear side. Now we will make some modifications on the blind flange, like the inside diameter, and here we will change the whole diameter of the bolt, the number of bolts, change the raised face diameter, and number of passes. Okay, here's some other options for the guiding pin. You have the ability to add guiding pin, jack screw, select the suitable size, and if you would like to modify it manually, just click on user define. We will add a vent hole, and let's define the vent hole diameter and vent hole angle. By clicking on save on this button, SEG will detect the parameters or the relationship between parameters. You can figure that the tree here make a refresh because according to this image here, SEG will use the relations that we did automatically, like the outside diameter of the connected flanges shall equal each other. The bolt circle diameter should be the same. The inner diameter includes the clearance. Number of bolts should be the same for the 2 connected flanges. The raised face diameter, the diameter of bolt hole. So SEG will automatically make this relationship. So if we come back to this flange, for example, you can figure that the dimensions will be reflected automatically for holes, for example. Now we will open the shell and modify the longitudinal welding line orientation and the length of this shell course, and let's click Save This. Save This means you will save this item only. If there is any other relationship, it will not modify it. It will modify it when you click Save. Okay. Now if we come back to the tube sheet, you can figure that we have those. If you would like to add a vent hole, you can make it and click Save This. Okay. And for this shell course, we will select it and define the length of this shell course and click Save This. And let's add another shell course to the tree. Here, shell side in 2. And let's make it looks like the shell side for the second shell here. And let's modify the length of this shell course, and let's click save this and move it after the the first shell course here. So from move, we will make it move after and make it after the shell. So we have in the shell side flange, 2 shell courses after that another flange. We will select the rear flange and make some modifications for the inner diameter of this one. Change the bolt flange outer diameter, and here the bolt raised face and bolt circle diameter, bolt number and number of bolts, and let's click save. In this case, we will click save to reflect those dimensions on the connected flange for the shell side, because as you know, if we open this figure like that, and here those connected flanges here for the shell side and rear side, they should be with the same dimensions from outside and bolt circle diameter, number of bolts, all of that. So we will click on save to reflect that. Now we will modify the third shell course. Here, let's select this shell and modify the longitudinal welding line orientation and the length of this shell course, and let's click save this. Now we will start creating the model of the exit changer here, like that, and you can figure that the blind flange takes place with the pass partition and the vent hole. After that, the second element for the front side, which is a gasket, according to this tree, we have a flange. After that, we have a gasket, another flange. So each item will take place and create and assemble automatically to the model. Now let's discuss some points regarding to the tube sheet hauling, and that's a new module. We make it on SEG software. If you would like to make your whole pattern, and if you don't have HTRI to generate the CSV file, which includes the tube pattern arrangement, from edit here we will select the tube pattern. So that's the standard tube pattern. Rotated square 45 degrees, rotated triangle 60 degrees, and those are the standard types. For example, if we select this type and select the big point from here, so that means the big point will be on the middle or on the center of the tube sheet here. And let's select the center, and let's try to create this, and you can figure that this shape comes like that. If we make the big point to the center point of the hole, you can figure that we start from the center of the hole. Let's change the arrangement and select the square rectangle, and from here select the big point to the middle, and let's draw. And you can figure that the arrangement starts from the midpoint of this shape which we selected. And if you would like to start your arrangement from the center point of the hole, just change the arrangement like that, and the arrangement of tubes shall take place like this. Okay. Now let's come back to our model here. Now we finish the shell course and start creating the rear end. Okay, let's close this. Here the second shell, the last element for the rear side, which is ellipsoid head. Now we have the complete shape of the main items of the shell course. Now we have this welding line the same for that one. So we will change it and add some elements, another elements like nozzles. So we will select the second shell type right here and change the orientation of this welding line and click save this. And let's add a pass partition to this shell. We come here and make a section to this AES exchanger. So let's take a section like this. Sorry. We need to add a pass partition here. So let's open SEG, and from here we will select the shell, and from elements we will select front pass partition, and let's add a pass. From here you will find many types of passes. Let's set 2 passes to be the same, and define the extension on the right side and extension to the left side, and click Save. Let's add a new nozzle, N1. Let's make this nozzle as a long weld neck nozzle. Size, location, and orientation. Let's click Save and modify the projection of this nozzle. So that's the projection from the vessel center line to the facing of the flange, and then let's click Save. Now we will add another nozzle, N2, and we will make N2 looks like N1. So from here we will make it looks like N1 and click Save. Okay, now we will come back to N1, and you have the ability to make a rename for this nozzle. For example, hot inlet. Okay, and we could add a nozzle load to this one. And for N2, we will do the same as outlet. That's the name of the nozzle. And you have the ability to add nozzle loads. And let's click Save. Okay, now we will change the orientation of N2 to be at the bottom. So we will change the orientation. And for the shell side, let's add another 2 nozzles. N3. And let's make it as a long weld neck nozzle. Select the size, 6 inches. The location, the orientation, and let's click Save. And from here, define the projection. Calculate the required projection. Okay, let's add another nozzle, which is N4. Okay, and we will make N4 looks like N3, but we will change the orientation of it and the location. So we will come here and change the orientation, okay, and change the location of this nozzle, and click Save. Now let's add the vent and drain to the rear side. So let's add the vent hole. From here, let's select long weld neck. And you can figure that you have many types of nozzles here. 0 degree, and let's calculate the projection. Let's add another nozzle, which is a drain nozzle, and we will make it looks like the vent. Okay, but we will change the orientation to make it at the top, at the bottom. Drain. Click Save, and this one we will make it as vent. Okay, now we will start creating those items by clicking on Start here to start generating the pass partition and nozzles for the heat exchanger. During that, we will complete our discussion about the pattern holding for the equipment. Let's make an edit, and from here we will define the exchanger inside diameter and the clearance between the inside diameter of the shell and the tubes, which around the OTL of the tubes, but it's not the same. Okay, from here we will make this the beach and the tube OD, and from the tube bosses we will select the required tube bosses. For example, if we select this type of tube bosses, for example, and click Draw like that, and if we come back to the pass lane partitions, you have the ability to move the pass partitions up and down, and you can figure that the number of tubes in each room will appear in each side like this. Okay, so if we move it a little bit down, you can figure that the number of tubes in the top room increase and decrease on the bottom two rooms. And if you would like to make this movement asymmetric, let's come back to the cube sheet, and from here let's make the movement asymmetric by clicking on symmetric vertical movement and symmetric horizontal movement. And let's draw again like this, and by selecting path lane partitions, if you make move up, for example, like this, you can figure that the bottom room and the top room are identical because the path partitions will move in a symmetric way. Okay, let's go to the path partition and select two passes. And from here, from holes, we will define the tie rod diameter and the tie rod hole diameter on the baffle, the ceiling rod diameter and the ceiling rod diameter on the baffle. And let's make the symmetric selection right here. And we will select the tube layout. And for that, if you would like to make the hole in the tube sheet is straight without a chamfer, select type 1. And if you would like to make it with a chamfer at the end like this, you will select type 2 and define the chamfer value right here. For the tie rod position, we will select the tie rod position and define the depth of the hole on the tube sheet, define the drilling angle. And from here, we will define the end of the tie rod. It's 14, but the nut for the end of this tie rod, we will make it 10 millimeters. And for the ceiling rod, we will define the same, the depth of the hole and the drill angle. And from here, we will select the size of the nut. Now let's click draw to generate the model like this. And let's make one more modification by increasing the age of this one. And let's click draw. Let's come back to the model here. You can figure that we make the model like that. And let's change the orientation of this nozzle and that one first. But right now, from here, we will change the path lane. Let's increase it a little bit, for example, and click draw to increase the path lane between the path partition and the tube. And let's create some tie rods by clicking on the tube and convert it to tie rod like this and like this. And for the ceiling rod, we will select that one to convert it. And you can figure that it will be reflected on the 4 quarters by selecting the symmetric vertical checkbox and symmetric horizontal checkbox. Now we will export those data right here and close this form. And from here, let's add some elements like baffle 1. Okay, and you can figure that you have many different types like segmental, baffle, 2 pieces or another types. Let's define the inside diameter, the baffle cut, the spacing, the thickness of the baffle, the location of this baffle, the orientation, and the vent hole, and the number of baffles. We have 7 baffles. Let's add another baffle. Okay, and let's make it looks like baffle 1, but we will change the location and orientation. And let's click save. Now we will add the end baffle. From here, let's select end baffle. Thickness, define the location, orientation, vent height, and click save. Now we will change the orientation of those 2 nozzles. Let's make this one like this and make that one on 0 degree and click save. Now we will start the assembly. Okay, now we will make the arrangement of the tube bundle. And during that, we will discuss some customization of elements like the support saddle. In SEG software, we support many different types of saddles, and you can figure that for this type we have this web without any edges, and we have outside web here. For the second type here, this web includes a straight edge, and this straight edge goes to the center of the bezel and without any outer ribs. And for this type, this mid-rib includes a straight edge, comes down to the bottom of the bezel and without any outer ribs. And another type for lifting saddle. And this type of lifting saddle, one of our customers in USA asked us to make this type because they are usually used at not those types. Okay. And for each one of those types, you can figure that you have many different options on each type. Like you have the ability to make change the bottom width of each one and control the location of the web, make it on the left side, right side, or on the middle side. Let's come back to the model, our model here. Now we've done this. Let's add some elements like tubes and floating head. So from here we will select the element and create tube here, and you can figure that you have the ability to select between standard tube length and or user defined or bended tube. For tube, let's select this tube and select the length of this tube and click save, define the thickness and material. Now let's add a tie rod. Okay, let's define the tie rod length, the location of the nut according to the image on the right hand side. The size of the nut, we defined it as 10 millimeters. Let's add sealing rod. Size. Okay, let's add a floating head. Here. According to this figure right here, you will tell those data, and important point to define the tube length according to your selection on the right side. We will change the bolt diameter and change the diameter of the hole, and let's click save. Let's add a sliding bar. Okay, on this sliding bar, let's define the side diameter of the shell, define the length, define the location and the height of this one. But let's select another type. You can figure that you have other types. And the location, and let's click save. Okay, now we create a new items like tube, tie rod, sealing rod, floating head, and sliding bar, and let's add another internal which is the impingement baffle for nozzle NS3. So from here we will select internals and select impingement baffle. And from here, you can figure that you have many different types of impingement baffles, like this. And let's select this type and define the inside diameter, the thickness, and the height. Okay, define the location. It should be the same location of nozzle NS3 and the orientation. And let's click save. Now we will start creating the assembly to create the mentioned types. Okay, that's the tube, and let's come back to the slides. Here, let's complete our discussion about the available types of saddles. That's the first type of saddle, and as you can figure, you have 3 cases to control the location of the mid web. Make it on the left side or right side or on the middle. For the second type of saddle, which is include this edge right here, you have the ability to control the location of the web to make it on the left side, right side, or on the middle. And you have the ability to control the bottom width of the saddle. You have the ability to make it with straight edges like this, or make it narrow at the bottom like this, or make it wider at the bottom like this, according to the dimensions which mentioned on this figure. Here for this type of saddle, you can figure that the edge comes down like this, and the same options for the web location, left, right, or middle, and you have the ability to control the bottom width. The fourth type, which is the lifting saddle, you have the ability to control the same options for the web and the same options for the bottom width according to the figure right here. And many other options, like if you would like to make a cut on the web like this to suit the requirements of the client, and to make able for some cases the tightening area for the anchor bolt is a little bit tight. So sometimes you may need to make a cut on the web like this. So you have the ability to make a cut on the web like this. You have the ability to make the slot holes, okay, and you have the ability to make the holes, change the hole pattern from the long direction to the short direction like this, and you have the ability to add a large number of supported ribs like this. Let's come back to our model. Here, that's the floating head. The last element of the cube bundle, I think. Or I think we have a sliding bar after it. Let's take a look to the tree. We have, after the floating head, we have a sliding bar. Okay, after that, the impingement done. Okay, let's discuss some other slides during this one. For example, here, by using SEG, as we discussed, you can generate many different types of equipment, like storage tanks with a fixed roof, complicated shapes of pressure vessels, a piping on pressure vessels like this, and make some configurations like enclosures with some standards there, simple pressure vessels like this this air cooler right here, like that one. And you have the ability to create heat exchanger, stacked heat exchanger like this. Okay, let's come back to our model again. Here you can figure that we have the internals of the tube bundle, and we have here the impingement baffle. We open this tube bundle here, and let's start making the tube bundle arrangement at all. Let's open the tube sheet hauling, and let's start hauling the model. By using this form, you have the ability to import a CSV file from HTRI. But those information already filled by using our module for tube batter. Okay, so if you have HTRI file, you can export the CSV file and import it here from this form. So here we start the hauling, and let's come back to the model here, and let's take a look. Here, SEG will start creating the hauling on the tube sheets and make the pattern for tubes. The same thing will take place for the second tube sheet here. Okay, and let's take a look to the tubes. The arrangement of tubes will start. And the same for baffle hauling. And all of us knows that this step takes a lot of time from us to make it by a manual way. It's consumed a lot of time and a lot of headache. But by using SEG software, as you can figure, it's so easy to make something like that, and it takes minutes from you to generate the tube bundle arrangement and baffle holing, tube sheet holing, arrangement of tubes, tie rod arrangement, and sealing rod arrangement. So in minutes you can figure that all of that is done. Alhamdulillah. Okay. Here's the last thing. Here the holing of tie rod and sealing rod on the baffles and tube sheet. The last step, inshallah. Okay, now we have the complete module for the heat exchanger. The last thing is the tie rod holing. Okay, now we have the complete model for the tube bundle, and you can figure that we have the length hole for the tube sheet as we defined. Okay, now let's open the tube bundle assembly. So let's click on this one and click open to open the tube bundle assembly. And from here, let's pull this form and let's add support saddles to the model. So let's select this shell course, and from here, let's select the support saddle. Okay, so from here, we will select the type of saddle. Let's select this type with a lifting lug and the width on the left side. Define the height and the height of length with offset. Let's add a mid-rib and intermediate ribs, and let's make the spacing like this. Let's add a wear plate, define the base plate length and the bottom width of this one, base plate thickness, hole diameter. Okay, and let's make this as a sliding hole. Okay, and from here we will define the location of the saddle, the orientation, and let's click save. Now let's add another saddle, saddle 2, and let's come here and select this type of saddle with lifting lug but the width to the right side. Okay, and let's define the same dimensions, height to the offset. Let's add a mid-rib and another intermediate rib. Let's add a wear plate, define the bottom width and bottom width here, the thickness of the base plate, the hole diameter, and the offset of the hole from the edge. Okay, and from here we will define the location of the saddle, and let's click save. Okay, now we will click start to start creating the saddles like that. And during that, let's discuss some points according to the HTRI view. Here for this form, if you have HTRI model, you have the ability to export the CSV file. This CSV file includes the tube pattern arrangement. So by using this form, you can import this CSV file from here and modify some data according to that, like the hole type and sliding rod, sealing rod dimensions, because it's not included in the CSV file. It's just give you the location of holes in X and Y location for each tube. So by using this form, you have the ability to make tube arrangement if you have a design tool like HTRI. And we discuss this feature for if you would like to make a tube pattern by hand, you have the ability to make that by using this tool. Let's come back to our model again. That's the second saddle. Okay, now we will add some connection bolts to the connected flanges. After that, we will proceed to create, inshallah, the general arrangement drawing for the equipment and generate the tube bundle arrangement drawing. After that, inshallah, the tube sheet drawing. Okay, now we will come back to the 3D model here, and now we add saddles. Let's remove this section, and now you can figure that we have this AES heat exchanger like this. And if we take a quarter section here, continue and make another cut, you can figure that we have this arrangement, this pass partition here. And if we take a look to the gasket and the connection for each one here and there, now let's add some connected bolts to the flanges. So we will select the blind flange from here, and let's add bolt stud 1. And here let's select the bolt size, select, and click save. And let's add another connected bolt to this flange. Same, we will select the size and the length of the bolt. And for the last flange, we will add another stud. Here, let's define the dimension, the length, not spacing, and click save. Now we will start the assembly to start creating the assembly of the nut and the arrangement of the connected stud bolt for the flange connection. Okay, now let's come back to our presentation here. And by using SEG software, you have the ability to create a bill of material, complete bill of material for your project, and you have the ability to export it in Excel format. The same for the cost report. You have a tool to generate estimated cost or estimated material cost report by defining the price of each material per ton, and you have the ability to export it in HTML format. Another tool for hauling. By using this tool, you have the ability to make a nozzle cut on the shell or the head. So if you would like to make a flat pattern for shell blades, you will get it easy after making the nozzle cut on the shell. Another tool for sheet metal flat pattern. By using this tool, you have the ability to create a flat pattern for shell blades and make export it in DWG extension, DXF extension, and you can export it as a flat pattern for a nesting after that. Okay, the 3D model, you can export it in many different extensions for the other CAD softwares like SAT extension, STL extension, STEP extension, CATIA part or CATIA product, another different extensions. The same for the drawing. You can export your drawing to DWG format, DWF, DXF, many different extensions you can use it or export your model to it. Here if we come back to the model, now we have this exchanger with all tightening bolts like this, okay, for all sides like that, and the complete tube bundle, and that's the tube bundle here. Okay, with the holding on one. Now let's close this one and come back and create drawings for our model. Let's come back to SEG, and from here you can figure that we have separate groups for the front, tube bundle, shell side, and rear side. And you have the ability to create a drawing for each one of those groups separately. And here we will generate the general arrangement drawing for all exchangers. So from drawing, we will select all, create drawing, and from here we will select this size of the drawing. Let's make it A1. And from this tab, we will make two sides. The first side, which is elevation view and back view. And let's make the spacing between views with 8 millimeters or centimeters. And from here, we will select the left view to be left view and make the style without any hidden lines. We will remove all hidden lines. We will keep the visible lines only. And from here, we will define the location of the heat exchanger on the drawing. And this location defined by centimeter. Define the scale of the heat exchanger. And from tables, let's select bill of material table, design data table, flange table, nozzle load and nozzle table, gasket table. And from notes here, you have the ability to add more notes or import notes from Excel sheet. If you have an Excel sheet, standard notes, you can import it. You can edit or add or delete or modify on the current notes. For the welding details, you have the ability to add more welding details to your drawing from this wizard, which is a huge library for details. We will select it from here and select the client document list and the visual document list. And the same, you have the ability to add or edit or move or delete. Okay. Now from the title block, let's name this drawing as General Arrangement Drawing. Okay. Let's move. And DWG 001. And let's edit the revision. It's revision 0. Issued for review and approved checked by. Let's add some empty rows here. And from design tool, design style, we will select one sheet only, and we could discuss this tool in another meeting, inshallah, and click create drawing to start creating the drawing of the heat exchanger. You can figure that the size of the drawing is changing automatically. The views of the heat exchanger takes place automatically, and you can figure that the revision table takes place, and the bill of material list filled automatically, and it will be sized automatically, and it takes place on the right place of the drawing automatically after filling all information or all data of the bill of material. Okay. Okay, now the bill of material is done and added. The design data table will filled with the data that we entered on the equipment data. Those data right here, all of those data will appear on the drawing, and if we will make some modification for this point, we will change some information in this design data and reflect it on the drawing, and I will show you how to make a reflection after modifying. Here the notes table, nozzle table, gasket and flange table, maximum allowable nozzle load, and the client document list and visual document list. Now we will import the welding details automatically that we select from the SEG library to the drawing. Here, like this. Okay, after finishing this, we will make some modifications on this drawing, like let's move this one a little bit and increase the width of this one. Let's move this table a little bit up right here and change the size. Let's move this table down here and let's add some standard blocks like shell loads. Okay, and from here we will make a modification to the design data, and let's make this style is with hidden style. So let's come back to the general arrangement drawing and click create drawing, and from here let's select this style with hidden lines. So by selecting this style, you will make the view with hidden lines. And from table we will remove all tables, and let's keep the design data table only. Okay, and click on update tables. Let's save this information first before starting, and let's make a modification here on the design data table. Let's remove all the checkboxes here and select some fields only, not all fields of the design data. Okay, and you have the ability to modify or edit, just modify the information, or you can import it from Excel sheet directly if you would like to import it, and click save. Now if we come back to the vessel and click on drawing, you can figure that we change this and that saved, and select design data only, and we will update to the design data by clicking on create. You can figure that here on this view, it will change it to be with hidden lines. So you can figure that all hidden lines will appear on this view. Okay. And the same for design data. You can figure that the information removed and will be refilled again. Okay, now we have the new design data after modifying. Okay, for our drawing, we can add a lot of things like bill of material item and the nozzle tag. By selecting the nozzle, and from here select the parts only, you have the ability to add the nozzle tag like this easily. And those names are the names on the tree that you modify it or create it on the tree. Let's add some dimensions like inside diameter of this side, inside diameter of this side, like this. Let's add it here. The length of shell courses. So adding dimension will not take a lot of time from you to make it suit and make it make sense. Okay, so after this step, you will add your dimensions to the model to make your drawing make sense. And let's create another drawing for the tube bundle. Here we have this assembly for the tube bundle. Let's select this group, which is a tube bundle, and create a drawing. From here, we will make this drawing as A2, size A2. And from elevation, we will select elevation only. We will not add another view. And from here, let's make it, we will look at it from the left view and make it with hidden lines. And from here, we will change the location of the view in the drawing, change the scale. And from here, we will add the bill of material of this one and remove other details. And from here, we will make it tube bundle detail, DWG 002, and let's define revision. Okay, and click save. Let's add another one, and from style here we will save this, and let's click create. Okay, now we start creating the tube bundle drawing with complete bill of material, and now we will make some sections and add another details to this one. So from here we will select the section view, and let's create a section from this side like this, and another section for the tube bundle like this. And you can figure that that's a floating edge with a splice plate here. Let's add a detail for another section for this exchanger from the middle. Sorry, let's select this view and select section. So let's select section view from here. And if you would like to add dimensions, like chain dimensions here, like this. It's easy to do it and it will not take a long time. You can make all of that in minutes, inshallah. So you can generate dimensions like this. And if you would like to add the tag of each element like this one is baffle 1, that one is baffle 2, like this. Okay. Now we will add some details for baffles. So from here we will go to parts and select the baffle. That's the first baffle. Define the scale of this one. Click OK, and let's move it here. And let's select the second baffle. And let's move it here. third baffle, same here. After that, you can add dimensions to this one. Okay, regarding to the sliding bar cut, let's come back here and let's open one of those saddles, one of those baffles. Here, let's open one of those baffles. Here, let's open this first baffle, and let's create a sketch here. And in this sketch, we will make a projection for that one, and click Finish. Now we will open this one right here, like this, and make a modification on this one. Let's take a look on the other side. Sorry. Like this. And now we will make this cut on the baffle and make fillets. So let's click Extrude. Let's select those shapes and make extrude with cut and through all, like this. Now let's make a fillet to those edges here, like this, and define the fillet radius, like that. Now we have this cut, and it will be reflected automatically to the drawing of the baffle. So if we come back here, you can figure that we reflect this cut, like that. Now let's make a detail for the tube sheet. Okay, and that's the last drawing for this equipment right now. From drawing, we will select create drawing, and let's select the size of the drawing. And from here, let's add other two views, and let's make let's make the spacing between views is 10 centimeters. And from here, select the left view and define the location of the tube sheet, the scale of the tube sheet, and from here, let's select a welding detail. Let's remove all of that, and let's come back here and select the tube to tube sheet connection, and let's click Save. Okay, and from here we will modify the revision. Okay, and tube sheet 1 detail and DWG 003, and click here Save and click Create. Now that's the detail drawing for the tube sheet hauling, and that's the tube sheet hauling detail, and you have the ability to modify it by the iLogic to suit your requirements. For example, let's open the browser, this one, and open that one. You have the ability to modify the tube sheet thickness, for example, the location of this cut right here, so you can move it. So let's make it on millimeters from this side, increase the spacing, so you have the ability to control this. After saving that one and close it, will reflect directly to the drawing. Okay. Now, if we would like to add some center lines automatically, we will select this tool, this feature to add center lines like this, and let's add some dimensions like side diameter here and there, and the spacing of that one, and let's define the whole of the tube sheet. If we select this one, for example, you can figure that that's the tube information. It's this diameter of the hole, and if you would like to add the quantity, for example, of this one, let's make that like this, and let's import the where is the size of the number of quantity, this one, sorry. Okay, and let's click Save. Now we have 140 holes for this one. We will make the same for the tie rods. Let's make edit. Let's edit it. So from here, Okay, let's add this one, and for the tie rod, the same, we will do the same. Let's add the quantity. So we have this quantity right here for each one. Okay, you have the ability to add dimensions, building details. For example, if we would like to add a detail for this vent hole, for example, 1, 2, 4, like this. And if you would like to add a hole detail for this one, okay, so it's automatically mentioned that. Okay, now you can figure that in less than 14 minutes, we create the 3D model of the AES heat exchanger, and it's one of the difficult configurations of TEMA types. And you create detailed drawings for this heat exchanger, like the general arrangement of this type. Okay, just we need to add some dimensions, tube bundle detail, tube sheet detail, all of that in less than 14 minutes. Okay, and you can figure that no existing software can do all of that in minutes, like SEG, inshallah. We will make another demo for the kettle time. Okay, so let's close those drawings and let's create another demo. So let's come back to this project, and from here let's create a new project. Demo. EKU, and let's select the project location on the desktop and select heat exchanger and click finish. Okay, now we have this exchanger. Let's make a name. Okay, and from here let's select the setting as we define the setting of the equipment, and from here you would like to make a review for the items during creation. Now from assembly we will open exchanger, and from the kettle type we will define the clearance and start creating. At this time we will select the front side as B, which contains head, shell, and design flange, and for the shell type we will select K, which includes design flange, cone, shell, and head, and for the rear side we will select U. So we will have this type of exchanger. By clicking on build, we will get this exchanger here, and we will get this to be automatic. Okay, now let's select the shell, and from here let's define the inside diameter of the shell, define the longitudinal welding line orientation, the length of the shell course, and let's click save as we discussed before, because clicking on save will reflect the parameters, the other parameters on the tree. And if we click on FX parameters here, start making fresh, you can figure that we have automated relationships between parameters for each item. And for this flange, we will change the bolt diameter, for example, and bolt number. And let's click save to reflect this change on the other sides. And let's select the cone front plate on the shell side, and we will change the dimensions of this cone. From here, that's the start diameter with a meter, and the end diameter if we change it to 1.5 meters. Change the length of the cone, and let's click save, because we need to reflect the end diameter to the shell and head, which they are after the this cone. So if we come back to the shell, you can figure that the inside diameter of the shell is changed. Now let's change the orientation of this shell course and change the length. And let's click save this to save it only for this shell. Now let's click start the assembly to start creating the model like that. Okay, so we have this bonnet, which contains from head and shell, another flange. Okay, now let's make the tube pattern for this tube sheet during the creation of this exchanger. So let's come back to the tube bundle, and from here let's click edit and define the shell inside diameter, the clearance between the shell and diameter, define the tube diameter and reach. Okay, like this, and let's select the tube passes as a one pass, and let's define the pass lane 150, and let's click create drawing, and you can figure that you get this arrangement. But don't forget, in this type we will make a U-tube or the bended tube. So this one is a one tube. Okay, so let's save this and come back to the model right here to figure out the other items during creation. We have that cone, the other shell, after that the end head. Okay, now we have those items are created, and let's make the saddle on this cone and another saddle here. After that we will make the tube pattern. So let's select this cone, and from elements let's select the saddle. And from here let's define the dimensions of this saddle, the height, contact angle, and select the type 5123 according to the images right here. The straight edge, if we have a straight edge, let's define this like this, and that's the base plate. And let's add a mid-rib and another mid-rib and intermediate rib, for example. If we need to add intermediate rib, define the location of this one. Sorry. Okay, define the hole diameter, base plate thickness. Okay, the location of holes from the long edge and the short edge. And now let's click make it as sliding holes, define the holes and make 2 rows of holes, and let's click save. Now let's click start simply to start creating the saddle on the conical shape. And during the creation of this saddle, let's complete some slides of the presentation. As we discussed in the drawing, you have the ability to add tables to your drawing, like division table, bill of materials table, design data table, nozzle table, many other tables. You have the ability to add it. Okay, and for the nozzle table, for example, you have the ability to add more information, all information of this nozzle, like tag, service, nozzle size, outside diameter, scalable, internal projection, external projection, reinforced band information, orientation of the nozzle, facing, connected flange and blind, and the welding details. All of that you can define it on the nozzle table, and you can control the exported information to your program. So if you would like to remove, for example, if you would like to remove the nozzle thickness, or if you would like to remove the facing flange and facing information, or welding detail, you have the ability to do that. Okay, and you have the ability to create your border from our list. So if you have a standard border, you will send it to us and we will import it in SEG database, and you will be able to use it anytime. So let's come back to the model after creating the saddle. So this saddle is connected to the cone, and let's make a section on this one and create the bended tube. From here, let's make a half section, and let's add a bended tube to this tube sheet. Let's add a tube. And from here, we will select a bended tube and define the length of this tube, define the thickness, and click Save. Now we will start the assembly. After making the assembly of or generating this tube, we will start creating the pattern of this tube to make the pattern of the whole tube arrangement inside the tube bundle. Okay, now we will open as a tube sheet from here, and we will open tube sheet tooling and click on Start Tooling. And now SEG will start creating the tube sheet tooling. After that, start creating the U-tubes arrangement, and if we have tie rods, steering rod, according to our information that we create for the tube bundle arrangement, it will be reflected to the model directly. Okay, and from here you can figure that the whole is done on the model. And let's take a look to the other side. Okay, now let's click Finish, and you can figure that we have this cubes like that. Okay, so now I think we need to add some bus partition models, all of that. So any questions regarding to this webinar? Devik, you can control from here.